Again, calculus students and lovers of truth, let us continue our lesson on antiderivatives here. And in this case, there's a nice rule that for antiderivatives of composite functions. And I should note, I can't mention and emphasize this clearly enough, this method that we talk about only works when the inside function is a linear function. So when you have like ax in here. If you were to have ax squared, ax cubed, ax to the fifth as the inside function, then this rule does not apply. Okay, so if the derivative of f is equal to g of ax, then the original function, or this function's antiderivative, is simply 1 over a times g of ax, where g is the antiderivative of little g. So let's prove this, and just proving this is just an exercise in taking the derivative. Well, let's consider what would be f prime. Right? So if you were given this function, what would be f prime? Well, you have a constant here in the front, 1 over a, times g prime of ax, and but you have to deal with the chain rule because of the inside function here, times the derivative of the inside, which is just a. So this would allow us to cancel this and cancel that. And so we would get that f prime of x would be equal to g prime of ax, big G prime. But we're told that big G is the antiderivative of little g. So we can, of course, rewrite this finally as f prime of x is equal to little g of ax. So that was a little abstract, messing around here with all these symbols. Let's put this to work on a very specific function. Suppose I have a function whose antiderivative is cosine of 3x. Whose derivative is cosine of 3x. What would be the original function? In other words, find the antiderivative. Well, if I wanted to take the antiderivative of cosine, then that would give me sine of 3x. That would give me sine of 3x plus the constant. However, when I go to check this, if I were to check, and I take the derivative, I would run into a little bit of a problem because I take the derivative of sine and I get cosine of 3x. The derivative of this big constant goes away, but because of the chain rule, I have to multiply by 3. Okay? So this doesn't quite work, right? The antiderivative of cosine 3x is not sine of 3x. So we have to put one constant in the front here in order to adjust for the chain rule. So now if I were to take, so this doesn't work, right? But now if I were to take the derivative, then I would actually get back to the correct answer. So f prime of x would be equal to 1/3. The derivative of sine is cosine 3x. The constant goes away. The constant that I'm adding at the end here goes away. Then I have to multiply by the inside function's derivative. So multiply by 3. And you see this goes away, and the 3 and the 1/3 cancel each other. So this is just a more practical example of what's going on up here. Again, you don't have to memorize these rules. It's more important that you know how to use them consistently and consistently well. Once again, I have to emphasize and hammer home this point. This only works if the inside function here is a linear function. So 3x is the inside function here. That's linear. 3x is linear, right? This does not work at all whatsoever if the inside is not linear. So this is a so let's looking at the next example here. We can sort of see why that's the case. So, let's say that I have a function whose derivative is sine of x squared. What would be its antiderivative? Well, naturally, I'm going to say you want to guess this would be negative cosine of x squared plus a constant. But this is incorrect. This is totally incorrect because look at what happens when we check. We can take the derivative here. F prime of x would be, well, the derivative of negative cosine is sine of x, with sine of x squared. But then you have to multiply by the derivative of the inside function, which is 2x. So clearly this is not correct. Well, let's try. So many people want to say that this would be negative cosine of x squared divided by 2x. All right? So they're thinking ahead. You know, they know that when you take the derivative of this, you're going to have to multiply by 2x. So maybe if we just divide by 2x ahead of time, then this would work. But let's check one more time, and let's take the derivative of f. Now, keep in mind, this is a quotient that we're dealing with here. So by taking this derivative, it involves us having to take the quotient rule. So that we have here the derivative of the top would be sine of 2x, sine of x squared times 2x times the bottom minus the derivative of the bottom, which is 2, times the derivative of the top, which is negative cosine x squared. All of this over the denominator squared. So once again, this is incorrect. Okay, this function right here is not the antiderivative of sine of x squared. And I'm going to do something right now that's going to drive many of you crazy, but I'm going to tell you that there is a solution for this, but it is beyond the scope of what we're doing. Okay? So we will, we may solve this later in the year, but this is a problem that we will solve in Calc 2. Okay? So if you're taking Calc BC, you will eventually solve this problem. If you're taking regular Calc or Calc AB, you're going to have to wait and take Calc 2 in order to see the complete solution to this problem. You can try to Google it too, but you're going to find some very gnarly answers with no real explanation. So I just want to do this problem, and to show you, to highlight the issue here is that this rule that we talked about above only applies when the inside function is linear. Whenever the inside function is not linear, like this thing here is actually a quadratic, then the derivative or the antiderivative is actually quite tricky in order for us to figure out. So I will end this video here, and we'll start another one when we'll just work through a lot of examples. But I hope that you take away the main points of this and how to find the antiderivative of functions that involve the chain rule, and also cases where this rule does not work.